Today we are going to discuss about Unit 4 in Information Management. So the first topic in Unit 4 is Information Security. So information security means defending information from unauthorized access or unauthorized user. So it helps us to protect the data from unauthorized access is called information security. Information security is the process of protecting the intellectual property of an organization. Intellectual property means patent and copyright of an organization can be protected through information security. Now we are going to discuss about the basic principles in information security. Confidentiality, integrity and availability is the heart of information security. First one is the integrity. So the data integrity provides the assurance of accuracy and consistency of data over the entire life cycle. So when you're talking about availability, the information must be available whenever we are in need of data. The computing system helps us to store the data and process the information. The security control helps us to protect the data. The communication channel used to access the data. So it basically the availability helps us to protect or prevent from the denial of service attack as well as flood of incoming message to the target system. And third one is the authenticity. So whenever the data is delivered to the receiver, it must be associated with a digital signature. So it indirectly says that the message is delivered by an authorized person. That is called authenticity. Fourth one is the non-repudiation. So the non-repudiation giving assurance that someone cannot deny something. Non-repudiation refers to the ability to ensure that the party to contractor cannot deny the authenticity because they will be associated with the signature on the document. The next topic is the system testing. So system testing is when the software product is delivered to the customer. Before delivering the software product, it is tested by a software testing person. There are different types of testings are available. We will be discussing 10 different types of testing. So the testing the whole system. So when you are talking about requirements, you are having two different types of requirements: functional requirement specification and the system requirement specification. So it does not mean they will not talk about only the design. It talks about the believed expectation of the customer. So the types of testing are graphical user interface testing. Graphical user interface testing is when the application is developed, when the app is developed, the menu and the icons is called as the graphical user interface. Whether it meets with the written specification of the customer has to be tested using this test. Usability testing. So the tester has to check whether the app can be easily used by a first person who is going to use. It is easy to use. User-centered app has to be checked using the testing. Next one is the software performance testing. So we are talking about software performance testing. We have to check the responsiveness or the stability of the particular workload. When the particular overload is given to the app, what is the response and the stability has to be checked. Compatibility testing. So the OS, when the app is installed in the particular system, whether the compatibility of the app with the OS has to be checked. Load testing. The load testing is performed under both normal as well as the maximum peak load condition. So what is the bottleneck of the workload has to be find out. Next one is the volume testing. So the certain amount of data is given in a software application has to be checked is called volume testing. Stress testing. So beyond the breaking point we are giving the load. That is called stress testing. Next is the security testing. We should reveal the flaws in the security mechanism of an information system. scalability testing means scale up or scale out in terms of any non-functional capability. Sanity testing, what is the maximum calculation or the possibility the result can be true has to be checked. Finally, smoke testing. So they'll be testing to reveal the simple failure to reject the particular software app. In case the particular small failure is the reason we are rejecting the software to launch. That is called smoke testing. And third topic is the error detection and correction. In error detection and correction, so we are transmitting the data to the receiver. When we are transmitting the data to the receiver, what are the possibility of error has occurred? That is called error detection. The data will be sent in a bit by bit basis. You are having three different types of implementation techniques, that is automatic repeat request, forward error correction, hybrid automatic repeat request. We are having few different detection schemes where it is possible for us to detect the errors. So in case of single bit error in the sense we are sending the data 101 to the receiver. The receiver receives the data 100. So we can identify that a single bit of error occurred once it reaches the receiver. That is called single bit error. Repetition code. When you are talking about repetition code, the same data has to be repeatedly sending to the receiver. So while checking with the data which received has some difference, it is easy for us to identify that the particular data which we received has some error. Then in case of parity bit, so the parity bit in the sense we are using the code word along with the data. So you are having two different types of parity bit, even parity bit, odd parity bit. So the data which we are going to send is 1010. So you are having two ones in the data. That is called even parity. So we will be adding 0 at the end, which denotes the even parity bit. In case the data which we are going to send is 1110, there are three ones involved in the data. That is called odd parity bit. So we will be adding the code word as 1 at the end. So while seeing the code word itself, the receiver can identify what data the particular sender has sent to them. If there is any mistake, they can identify the data which they received has some error. And next one is the checksum. When you are talking about checksum, the data has to be sent are 1, 2, 1, 2. So the addition of 1 plus 2 plus 1 plus 2, that is 6. So while delivering the data, that is bit, to the receiver, they will be adding -6 along with the data bit. So the receiver, once they gets the data, they will be adding the entire bit. So the sum of all the numbers will be 0. So it denotes the data which they received are correct. In case if there is any modification, they can be easily identified that they'll have some error in the data which they receive. Next one is the cyclic redundancy check. Cyclic redundancy check the burst error. Burst error in the sense more than one bit of data has error while delivering is called single burst error detection cyclic code. So cryptographic hash function, the hash function is used and they'll be easily used to identify whether the changes of the data are accidental due to transmission error or maliciously introduced error. So next one we have to discuss is the error correcting code. The error correcting code in the sense they will be introducing the Hamming distance. So the minimum, before talking about the Hamming distance, how to calculate the Hamming distance. So we are delivering the data 40 to the receiver. In case the receiver received 0001, at the end every time they will be sending the data with a code word. So using the code word, they will be easily identified whether the data which they received is correct or not. So the minimum Hamming distance will be, so the d value is equal to 3 in the sense. So d minus 1 is equal to the Hamming distance. So 2, the minimum Hamming distance will be 2. So error correcting, you are having two different types, convolution code as well as the black code. Convolution code in the sense bit by bit basis. Black code in the sense black by black basis. Automatic repeat request. So we will be sending the data in 3 different types. Stop and wait, go back, selective repeat. Stop and wait in the sense the sender, they will be waiting for the acknowledgement once they send the data to the receiver. That is, one time the bit is sent to the receiver, the sender will be waiting for the acknowledgement. That is called stop and wait. Go back in the sense the frame has to be fixed in the starting itself. So they will not wait for the acknowledgement for every bit. They will be fixed the frame length. So they will be sending the frame length to the receiver. The entire frame length is sent to the receiver. Then only they will be expecting the acknowledgement. That is called go back. So the selective repeat, in the case in need, they will be requiring the data has to be retransmitted if they find a error in the particular message. So next one is the hybrid schemes. So it's a combination of automatic repeat request and the forward error correction technique. So the message are always transmitted with the forward error correction. First one is the message is always transmitted with the FEC parity data. So the receiver find it difficult to decode the message using the parity information. They will be requesting to retransmit the automatic repeat request. Second one is the messages are transmitted without parity data. If the receiver detects an error, it requests FEC information from the transmitter using the automatic repeat request. It is used to reconstruct the original message. So these are the 3 topics in the Unit 4 which we discussed by today. Thank you.